Hello, good day. We're going to talk about the Gauss elimination. So it is a method to solve simultaneous linear equations of the form A is 1 coefficient matrix variable equal to the constant matrix. So there are two steps in order to calculate or to solve the unknowns of the linear equations. So by Gauss elimination, so the first step is you use the forward elimination, and then after the forward elimination we use the back substitution. So in the forward elimination, it is to form the coefficient matrix into an upper triangular matrix. For example, if we have a matrix, a systems of linear equations, so we have three unknowns. So this is the coefficient, the unknowns, and the constant matrix. So the matrix by forward elimination, this matrix will be transformed into an upper triangular matrix, so like this one. So these coefficients will be 0, so transform na to ni 0 in order to transform it into an upper triangular matrix in order to calculate the unknowns x1, x2, and x3. So if we have a set of n equations and n unknowns, so we have from the first equation a sub 1 1 times x sub 1 plus a sub 1 2. So this is column 1 row 2. So this is times x sub 2 plus a 1 3 times x sub 3 plus etc. plus a sub 1n. So this is the number of unknowns times x sub n equal to b sub 1 2 ingon sa a sub n number of rows times sub 1 times x sub 1 plus a sub n2 times x sub 2 plus a sub n3 times x sub 3 plus plus n sub a sub n times x sub n equal to b sub n. So this is the last equation. If we have n equations and n number of unknowns, so in order to solve the unknowns of these equations, we need, in forward elimination, we need n minus 1 steps of forward elimination. So if we have 10 unknowns, so in forward elimination we need only 9 steps. After the 9 steps, we then again use the back substitution. So in order to transform this equation into an upper triangular matrix, what we're going to do is to multiply the first equation by a sub 2 1 divided by a sub 1 1. So multiply of them, and then the resulting product will be this one, a sub 2 1. So and then after this one, after you multiply all of the equation 1 with that multiplier, subtract the resulting equation with the last equation, a sub n. So this one, so subtract until the end of a step. So this will be, so kita subtract na to, so b2 and b1. So this is a sub 22 minus a sub 21 divide a sub 11 times a sub 12 times x sub 2, etc. So after that, subtract na to. So this will be next the step 2. The step 2 is the back substitution, where this prime, so kaning prime, so this is the the difference between this one. No? Ano siya? A sub 2 prime. So this is your new coefficient sa A sa row 2, column 2. So new na siya. Ano siya? It's a new value, new coefficient if you have a prime. So if you have second prime, this is the new value sa A sub n3, no coefficient. So after the last step, no, step n minus 1, so gamay na lang siya mabilin. So we now apply the back substitution, no? By the way, this is the resulting matrix. So if you apply those algorithm, so may mo siyang upper triangular matrix, ma-0 ni, ma-0 ni, 0. And then we can now apply the back substitution. So in back substitution, we can easily calculate the last coefficient, no? Where in our example, 3 equations 3 unknown, masolve na to ang x sub 3 by dividing the constant value by 0.7. And then masolve na to ang x3. The same with this equation, this formula, no? X sub n is equal to b sub n to the power of n minus 1 divided by a sub nn power of n minus 1. So this is the prime, number of primes. So therefore the general formula is this one, x sub I equal to b sub I to the power of I minus 1 minus the summation of a sub ij the power of I minus 1 times x sub j, no? So summation nila starting from j equal to I plus 1 padulong sa n, no? Divided by a sub ii to the power of I minus 1 for I equal to n minus 1 comma n minus 2 to 1, no? Padulong sa 1. So to understand this further, so let's have an example ta. So let's have an example. So this one, use same, and you will use the equation that we mentioned earlier, no? So we're going to use the forward elimination, and then after that we'll use the back substitution. So in forward elimination, so if it has 3 equations, 3 unknowns, so we need n minus 1 steps, so meaning we need 2 steps in order to finish the forward elimination. So this is by forward elimination, so we need n minus 1 steps. So if there are 3 unknowns, 3 equations, so we need 2 steps in order to finish the forward elimination. So what we're going to do is so we'll find a way para ma-0 ning 64, no? So we can do that by multiplying the first equation, the row 1, and then i-subtract na to ang row 1, ay multiply the row 1 by 64 over 25, so coefficient ani divide coefficient ani, and then i-subtract na to ning new value sa row 1, subtract na to siya sa row 2. So if we have a ratio of 64 over 25, no? This is 2.56. So this is just the coefficient ani divide coefficient ani, multiply sa row 1. So this is 25. So this is the row 1, 106.8. So multiply with 2.56. So the resulting value will be 64 na ni. 64. This will be 12.8. This is 2.56. This is 273.408 So next, so this is your new second row. So therefore subtract this old second row with this new one. So therefore this is 64 81 1772 minus this one, the new value 12.8. So this is 2.56. Then this is 273.408. So subtract, so this will be 0. This is negative 4.8. This is negative 1.56. This is negative 96.208. So this is your new second row. Next is to eliminate the coefficient of, so we'll make this one equal to 0. So same with this one. Now we divide 144, coefficient 144 with 25, and then subtract the resulting new first row with the third row. Okay, so this is the ratio or the multiplier. 144 divided by 25 equal to 5.76. So multiply this first row. So this is 25 106.8 times this is 5.76, and then this will be result will be 144 28.8. This is 5.76. This is 615.168. So subtract this one with this equation, the old equation, third equation. So this is 144 1279.2 minus 144 28.8 5.76 615.168. So subtract this is 0, negative 16.8, this is negative 4.76, and this is negative 335.968. So this will be your second row, this will be your new third row. So how many steps did we do? So this is the step 1. By the way, this is step 1. So this is the first step, by the way. So first step is to we'll find a way nga ma-zero ni. The second step is to zero this one, the row 3 column 2. So we're finished with the step 1, so we'll proceed to step 2. So in step 2, so our new column, our new matrix will be is now 25 5 1. So the coefficient matrix, since na 0 naman to, so this is 0, negative 4.8, negative 1.56, which is this one, this equation. And then the last one is this new equation, negative 16.8, negative 4.76. So A1, A2, A3, this is 106.8, this is negative 96.208, this is negative 335.968. So this is our new matrix. So as you can see, we're finished with step 1. So let's proceed with step 2. So in step 2, we're going to find a way that ma-zero ni. So by doing that, multiply nato ning row 2 with the multiplier 16 over 8 divided by 14, 4.8. So therefore, this will be negative 16.8 minus 4.8. This will be 3.5. So this is 0, 4.8, 1.56, 96.208 multiply with 3.5. So therefore, this is 0, this is negative 16.8. So 3.5 times 1.56, 5.76. 3.5 times 96, it is negative 336.728. Next, we subtract these two, the new and the old value of row 3. So this is 0, negative 16.8, negative 4.76, 335.968. So this is minus this new value 16.8, 5.76 minus 336.728. So subtract. So this will be 0. This will be 0.7. This is negative 0.76. This is now our new row 3 or the third equation. No? So this is the step 2. We only need 2 steps, so meaning we're finished with the forward elimination. So let's update. So our new matrix now is 25, 5, 1. So this is 0, negative 4.8, 1.56, 0, 0.7. So this is this one, no? Then this is a sub 1, a sub 2, a sub 3. Then this is 105.8, and then this is negative 96.208. This is 0.76. So we're finished with the forward elimination. So we'll now use or apply the back substitution. So back substitution is we use the third equation, no? So the third equation is this one, where 0.783 is equal to 0.76. So we divide 0.76 by 0.7, so therefore a sub 3 is equal to 0.8571. So that is our value for a sub 3. So how about for a sub 2? So in the second equation, this one, no, this is negative 4.8 a sub 2 minus 1.56 a sub 3 equal to negative 96.208. So na naman eh, no? So therefore a sub 2 is equal to, so transfer this term to the right side, so negative 96.208 plus 1.56 times 83, which is 1.08571, so divided by this 4.8 negative. So therefore a sub 2 is equal to 19.6905. So that is a sub 2. So to solve a sub 3, we use this first row, the first equation, which is So a sub 1 plus 5 a sub 2 a sub 1. And then this is 100, wait, 105. So this is 25 plus a sub 3 equal to 106.8. So therefore, a sub 1 is equal to 106.8 minus 5 a sub 2 minus a sub 3 divided by, we transfer these two terms, no, the right side, so divided by 25. So a sub 1 is 106.8 minus 5 times 19.6905 plus 1.08571 divided by 25. So therefore a sub 1 is equal to 0.290472. So this is our a sub 1. So therefore the unknowns are